Okay guys, in this last video we're going to take a look at a very important theorem, especially when it comes to polynomial functions. And this theorem is called the intermediate value theorem. And so when you hear intermediate, you probably think of some value that is in between two other values. It's intermediate. So when we talk about the intermediate value theorem, and what it does is it guarantees the location of zeros. Okay, and zeros being these x values that when we plug them into a function cause it to be at a height of 0. But the reason why it helps us find zeros is because, remember, with polynomial functions, if you take a look at this graph right here of this polynomial function, we know that polynomial graphs are continuous everywhere and so have this domain of all real numbers. And we also know that there are no sharp turns in these polynomial graphs. And so let's read the intermediate value theorem here and see what it really implies and talk about how this might be helpful in finding zeros. But it says that the intermediate value theorem implies that the point A f of A, which is this point right here, and B f of B, which is this point right here, are 2 points on the graph of a polynomial function such that f of A does not equal f of B. So what that essentially means is that there are these 2 points on the graph that are at different y values. If that's the case, then for any number d between f of A and f of B, and so what I want you to see here is this. We have this number d, and d is this height between f of A and f of B. It says for any number d between f of A and f of B, there must be a number c between A and B, so you see your c value down here, such that f of c equals d. And so what does this mean? Well, I suppose it means that if our graph has to go through all heights from f of A to f of B, then there is some x value that's between A and B that when we plug it in is always going to be at some height d that is between f of A and f of B. So it's kind of like saying you couldn't go from the height f of A to the height f of B on this interval of x values without having had some c value in between A and B that goes to every single height in between f of A and f of B. You have to go through all of these heights right here. So as we read the formal intermediate value theorem, it reads this way. It says let A and B be real numbers such that A is less than B. In other words, A is to the left of B, as we see on our image up here. If f is a polynomial, and here's the key thing here, if it's a polynomial function, that means continuous and smooth, such that f of A does not equal f of B, in other words, such that at the beginning of the interval it's at a different height than it is at the end of the interval of x values, then for this interval from A to B right here, f takes on every value between f of A and f of B, and that is to say that from f of A to f of B, it has to go through every height in between. And so why would this be something to consider? So what I'm going to have you do is, and I would copy this table that you see right here. This is just some problem that is in, say, a textbook that I pulled, but I like the table. And so this is what I've done. It says you can use the table feature of a graphing utility to approximate the real zeros or zero of a polynomial function. So as you look at this table of values here, I will say that this is for some function f of x. And so what I want you to notice is that f of x has all of these y values here. It starts at -11 when x is -2, and then it goes to a height of -1 when x is -1, then it goes to a height of +1 when x is 0, and then it kind of stays positive. I suppose the idea that I want to point out here is this. It went from negative to positive y values. And the reason why that's important is because if it went from negative to positive y values, what did it have to go through in between all those negatives and positives? It means that it passes through a height of 0 in between. And so that's what our mean or intermediate value theorem, intermediate value theorem guarantees. If we went from -1 to 1 between these two x values, then there had to be an x value between these two x values that goes to a height of 0. And so what we could do is we can draw a conclusion from this. I suppose, and I'll type this one right here just because my handwriting is better and I can do it faster. But we could make a conclusion here about the location of our 0 being between -1 and 0. So there must lie an x value between 0 and 1 that guarantees a y value of 0. So there must be a 0 between 0 and 1. So in large part, what we tend to do is, if I can't find the zeros, at least I can look at a table of values and narrow it down to what two values it might be between. So that's exactly what we're going to do here. My estimate for the 0 of this, and this is just because it goes from a height of -1 to +1 over a run of 1, that maybe it goes through a height of 0 perfectly in between -1 and +1. And so it would go through an x value that is a 0 between -1 and 0. So at x equals approximately 0.5, there must, we'll just put it this way, at x equals 0.5, we have a 0, or an approximate 0. So what I want to look at doing here is just using our graphing calculators to our advantage here. It says use the intermediate value theorem to approximate the real 0 of this function. This table's already been made for us, and what we're looking at is just maybe computing a few values on our own if they don't have a table. But after we get this table, we're looking for where our function goes from either negative to positive or positive to negative values, because in between these two values right here, there has to be a height of 0, guaranteed by our intermediate value theorem. So between these two x values right here, there had to be an x value that when we plugged it in, we went to that height of 0. So we can make an estimate as to the location of our 0. There must exist a 0 between -1 and 0. On that interval of x values, there had to be a 0. So if I had to speculate, maybe at x is approximately -0.5, there was a 0. So intermediate value theorem is going to allow us to make a table and find out where zeros lie just by looking at how our function crosses from negatives to positives or positive to negative values. Cheers.